Hi guys, so this is going to be our first online video for Programming 2. It took too long to get this out to you guys. I was trying to figure out the best way to do it, and I think that the best way to do it um, is really to just kind of work through the algorithm uh, completely, like in its entirety with you guys. And basically, I just recorded 40 minutes of video, realized it was too long, and then decided to start over. So here I am. Hopefully, I'll get it right this time. Um, we're just going to work through the algorithm, which might take a little while, just because a lot of stuff happens. But I think it'll really help you understand how this thing works. So there's also animations out there, but the animations go by so fast and don't really like go through the code at the same time. Um, and so I don't think they're the best way to learn this stuff. Anyway, if you go, actually, so here, I'll turn myself off for a second. So here's what you should do. Pause the video and copy down all this code. So pause the video here, copy heap sort code. Okay, pause it. Now that you've unpaused it, get all the rest of this in there, including print array and main. So pause it again, write that down. Okay, now presumably you've unpaused it. Here we go. I'm going to put my face back on the screen. Um, all right, so we start off at the heap sort. We call heap sort. The array that we're using is 8, 2, 10, 5. Now, quickly about heap sort. Heap sort's time complexity is n log n. Excuse me. It's n log n, just like merge sort, but it has a better space complexity than merge sort. Its space complexity is 1. The array only ever has to get stored one time. So, there you go. Anyway, the array that we're going to sort, as you can see down here in main, is 8, 2, 10, 5. And there are two steps to doing heap sort. The first step is to build a max heap. And I've got a comment here about what a max heap is, but I'm going to tell you anyway. So a binary tree, or a max heap is a binary tree with a special rule. And a binary tree is just like a family tree. It's a data structure, but it's a little bit special because in a binary tree, as implied by the name binary, each node can only have up to 2 children. So you can have one child, but you cannot have 3 or 4, and so on. Okay. With that, a max heap applies a further rule to that tree where none of the children can have a value that is greater than um, its parent. So, like, if your parent node is a 2, then the children could only be a 0 or a 1 or negative something. So we're going to sort 8, 2, 10, 5 because I picked a couple of arbitrary numbers, and that's what we're going to do. Okay. I should have grabbed myself another sheet of paper here. Um, hopefully I have one on me because I foolishly, uh, like I said, I did this video already and then realized it was like way too long and I was stumbling over myself. So I'll give myself some lined paper this time anyway. It'll make my life easier, even though it'll be smaller and ripped. Cool. All right. So the array is 8, 2, and I need to write this on the desk and not the mouse pad. All right, 8, 2, 10, 5. Get rid of this little corner here. Actually, let's just do it this way. 8, 2, 10, 5. Now, the trick is that right now, if I convert this array into a tree, it would look, or to a binary tree, it would look something like this right here. Like if I converted the array to a binary tree. And it's clear by looking at it that that is not a max heap because the child nodes have values greater than their parents. So step one, and what this first for loop does, is to create that max heap. So we are going to end up calling heapify twice in this for loop, but we're going to work through both times. So first off, we store the length of the array as n, and that is 4. The length of the array is 4. So we set I equal to n divided by 2 minus 1, which is 4 divided by 2, so 2 minus 1, 1. As long as I is greater than or equal to 0, we do I minus minus, which now you can see that heapify will be called twice. So the first time we call heapify, we are passing in for the array 8, 2, 10, 5. We're passing in for n, 4, and we're passing in for I, 1. So now we go to heapify. So in heapify, the first thing we do is we set up some pointers. So we're going to point largest at I, because right now we want to just store largest and we just want to point it somewhere. I was 1, so we're going to point largest at the moment, and you're going to want to probably write this, just keep track of your pointer. So on your array right now, it should be 2, okay? So you're going to have 2, and that's going to be I and largest. Both of those go right there. So I'm going to show this to you for the first few times so you get an idea of what I'm doing. And then after that, I'll probably assume you understand. So next we do the left pointer. Left pointer is 2 times I. Remember, I is 1, so 2 plus 1. And so that's 3. So left pointer is going to be pointing to 5 on our array, and I'll just put LP there. And then the right pointer is interesting because 2 times 1 plus 2 is 4, and our array only has 0, 1, 2, 3. So the right pointer is actually pointing off of our array. So this is what I've got on my paper right now. Okay, so we've got our pointers set up. Now we do some comparisons based on the pointers. So we have 3 total if statements, and the first one does some stuff with the left pointer, the second one does some stuff with the right, and then the last if statement only triggers if either of these two or both of them trigger. Does that make sense? So if any of these if statements run, or if both of them run, this if statement will run. If neither of these run, then the if statement, the third one, will not run. So that'll help us run through this a little faster. All right, so if the left pointer is less than the size of the heap, what was the size of the heap? The size of the heap was 4 at the moment. So we passed in 4, and left pointer is 3. So it's less than 4. So that first one checks out. Next, we check to see if the value of the array at the left pointer is greater than the value of the array at largest. Well, 5 is greater than 2. So we are going to move largest. Now remember, this is not swapping anything in the array. This is just changing some pointers around so that we can swap them later. So we're going to erase largest, and we're going to move it under LP, because that's where we think largest is right now. Remember, we're not sorting, we're building that max heap. So that's where we're at. Okay. Now, the right pointer is interesting because when we check this first condition, the right pointer is not less than the size of the heap. It is actually equal to the size of the heap, and so this if statement does not trigger. However, because the first if statement did trigger, we are going to perform a swap and then recursively call heapify. So if largest is not equal to I, and I is still pointing over there at 2, then we perform a swap, and we swap I and largest, or the values of I and largest, I should say. So you're changing your array to 8, 5, 10, 2. Okay. Now the pointers and stuff are still all in the exact same spots, but we have swapped the values. So now we are going to call heapify, and we are going to pass in the changed array, the size of the heap, which is still 4, and largest. And largest this time is going to be pointing to 0, 1, 2, 3. Largest is 3 this time. So When we come up through here and we run heapify the second time, largest is equal to 3. Left pointer is equal to 2 times 3 plus 1, which means left pointer is not on the array. And right pointer is 2 times 3 plus 2, which is also not on the array. This is important to acknowledge because since we know that neither of them is on the array, none of this happens. So we actually just exit heapify and jump back up here to our for loop in heap sort. So that's the first step in making our our max heap. So if I convert my array over now, let me make sure I do this correctly. I have, so this is step 2. We do 8, and then we have 5, 10, 2, I believe. Yeah. So now we're on step 2, which is this part right here. And that's if I converted my array to a tree. So hopefully that will make sense to you. But the for loop isn't done. We're going to call heapify again, except this time we're passing 0 for I, right? And that'll be the second time, so the loop will be over after this. So we jump down into heapify. We've got our changed array passed in. Size of heap has not changed. It's still 4. And I is equal to 0 this time. So first we're going to point I and largest to 8 because it's the 0 position in the array. So we do I and largest. Okay. Now we do the pointers. Left pointer this time is actually 2 times 0 plus 1. So 1, which means we're pointing LP to 5. RP, therefore, will be pointing to 10. Okay. So now the left pointer and right pointer are both on the heap. And so we're going to do a quick check. However, this time the left pointer, or the value of the left pointer, is not greater than the value of the array at largest. So we don't move largest here. But we do move it with the right pointer because the value of the array at right pointer is 10 and the value of largest is 8. So we are moving largest over under the right pointer. By the way, it helps to do this on a sheet of paper just so you understand exactly what the computer is doing. So that second set right here, that is where we're at. All right, so now, because one of these if statements triggered, this third one will also trigger. So if the largest is not equal to I, then we swap our stuff. So we're going to swap the value of largest with the value of I. So our new array is going to be 10, 5, 8, 2. And then we're going to call heapify again, and we're going to pass in largest, and largest right now is at 0, 1, 2. So we set int largest equal to 2, and then we do left pointer is 2 times 2, 4 plus 1, which is not on the array, which means right pointer is not on the array. If the left pointer is not on the array, the right pointer definitely won't be. Which means none of these if statements trigger, which means this third one doesn't trigger. So we actually just finished building our max heap. And so I'll draw that tree so that you can see that. So this for loop just finished running. Because when we come back, so after we exit heapify that second time, I is going to be equal to -1 on the third time this loop tries to run, and so this statement will evaluate false. That loop is over. So now we're going to be jumping into our actual sorting loop. Okay, so here's our tree right now. I really wish I knew how to like mirror this or something so that it would show up normal for you guys. I'll have to try to figure that out. I'm sure it's not difficult. I just haven't bothered to check. But our tree now has a root of 10, and then it has two child nodes because it's a binary tree, 5, 8, and then 2. So that's where our tree's at right now. Nothing difficult there. But that is a max heap. If you recall the rules or you read the rules in the comments up here, you'll note that that is a max heap, but it is not sorted. We sort from the max heap. So here's our second for loop. Now we are going to create an integer called size of heap, because even though we're not going to actually delete stuff from the array, we are going to act like it doesn't exist, basically, so that we can reduce the heap, and by the time the heap is fully reduced, the array should be in order. Because right now you'll notice it's actually in kind of reverse order. Um, Not quite reverse order, but close. Um, so anyway, the size of the heap is equal to n minus 1. N was 4, so size of heap is 3. As long as size of heap is greater than or equal to 0, we reduce the size of the heap by 1, perform a swap to reduce the size of the heap, and then we call heapify. So first let's perform the swap. First we are swapping the values of the array at 0, which is 10, with the value of the array at size of heap, which is 3. So 10 and 2 are getting switched. So go ahead and swap the array. So we have 2, 5, 8, 10. That can't be right. I screwed something up there. Value of the array at 0 with the value, because that would be sorted, so that can't be right. Hang on a second. I think I screwed something up there. So we had 10, 5, 8, 2. No, that's exactly what the code says. Value of the array at 0, which is 10, with the value of the array at the size of heap, which is 3. And perform the swap. Okay, so yeah, swap 10 and 2. 2, 5, 8, 10. Now, at this point, our array is sorted, but the computer does not know that. So it actually has to call heapify anyway. 2, 5, 8, 10 array is sorted, but we still have to keep going. Anyway, so we call heapify. We're passing in 2, 5, 8, 10 into heapify, and we are passing in 3 for size of heap and 0 for I. So int largest is equal to I. And don't be confused by what heapify does, because in the end the array is still sorted. Okay, so largest is equal to I is equal to 0. So we're actually going to say temporarily that that 2 is largest. And I know that's not true, but it's the same thing with where it built the max heap. It's just temporary. The left pointer is 2 times 0 plus 1. So 1. The right pointer is 2 times 0 plus 2. So 2. So left pointer is 5, right pointer is 8. Now, if the left pointer is less than the size of heap, so remember the actual values of left pointer, the actual value of the left pointer right now is 1, and the actual value of the right pointer is 2. If the left pointer is less than the size of heap, which it is, then we check the values. So if the array at left pointer, or value of the array at left pointer, is greater than the array at largest, then largest is pointing to left pointer. So we point largest to left pointer. We just got lucky that the array was sorted at this point. That's why this looks weird, because like you're like, wait, we sorted the array, now we're unsorting it, but this should work out. Okay, so so we moved largest to the left pointer. Now we're going to check the right pointer. The right pointer is less than the size of heap. The size of the heap is 3. And it's important to remember that we're not operating on the size of the array anymore. We're operating on this size of heap variable that decreases every time we call heapify. Just make sure you're aware. So now we are going to say if the array at right pointer is greater than the array at largest, which it currently is because it's 8 and 5. So we're going to move the largest to right pointer. And then in the third if statement, we swap the values of the array at I and the value of the array at the largest. So we're swapping the 8. We're swapping the 8 and the 2. Don't worry about it. I know we just unsorted the array. Then we call heapify again, and we're passing in largest, and largest is currently at 3. But I can already tell you that because largest is 3, that when we try to do the left pointer and right pointer, they're going to be they're going to be greater than the size of the heap. And therefore, heapify isn't going to get called again. So we just jump out back to here. Now, back in our for loop, size of heap just decreased. Size of heap is now 2. Now we're going to do our little swap, and then we're going to call heapify again. So the swap is going to go, we're swapping the array at 0 with the array at the size of heap. That's funny because that's basically undoing what we just did. And that's by nature of the way this array is set up, so don't worry about it. So we're erasing, and we're going to put 2 back where it was, and we're going to put 8 back where it was. So right now we should still have 2, 5, 8, 10. Even though we just called heapify, don't worry about it. So we swapped out 0, and we swapped out the array at 2. Now we're going to call heapify. We're passing in the exact same array that we passed in last time, but size of heap is smaller now. Size of heap is now 2. So let's look at how that affects it. Largest is I. So I is still going to be pointing at 0 because we're passing in 0, so it's still pointing at 2. Left pointer is going to be at 1. Right pointer is going to be at 2. However, it's important to note that this time the left pointer is going to get largest, but the right pointer is not in the size of, or is not less than the size of the heap. The right pointer is 2, the size of the heap is 2. So this is not going to happen. So we are moving largest to LP, which means we are swapping. And hopefully you can actually see what's happening here. But this is the part where like it helps to combine the animations with. But anyway, so largest is now pointing at LP. Because we made a change, we swap largest and I. So we're putting the 5 and the 2 back in place. However, because of the way things are, when we try to call heapify again, we're immediately just going to jump back out because of these if statements not getting triggered due to the left pointer and right pointer no longer being part of the size of the heap after we pass in a bigger I. So we're jumping back out. We're in this for loop again. Now the size of the heap is 1. Hopefully you can tell that because the size of the heap is 1, we're actually just going to put the 2 and the 5 back the way they were. And again, that's actually just due to the way that this particular array is set up. But we're going to we're swapping the 2 and the 5 back so that the array stays in order. My paper's starting to tear here. There's the 2. There we go. 2. So we're putting the 2 and the 5 back, and then we're calling heapify again. But for size of heap, we're passing in 1. When you pass in a heap size of 1, we're pointing I to the same spot, 0, and we're saying that largest is over there. Left pointer is 2 times 0 plus 1. So left pointer and right pointer are all, this is all staying in the same spot as it did last time. But the size of the heap being 1 means the left pointer is no longer less than the size of the heap, and the right pointer certainly isn't, which means heapify doesn't get called. Then we'll jump back to the for loop again, and now size of heap is equal to 0. We still have to run one more time. So we're swapping 0 and 0. Actually, this is probably shouldn't be greater than or equal to. I wonder if that's a typo I made, because if you're swapping 0 and 0, you're getting nothing, and then you're just calling heapify on a size of heap, which is 0. So actually, I'll have to double check, but I think that might be a typo on my part, this equal here. I'll have to check that and let you guys know. However, you can see now that this is pretty much over and the array stayed sorted. And then you might be wondering, well, like Mr. Carnes, we did a whole bunch of extra operations on the array. I don't get it. That's simply because of the way this array was set up. It's a small array. Um, and the values of the array that I chose, I guess, ended up this way. But that's how heap sort works, and I just wanted to work through it so that you guys would understand how to work through it and like see how each of these algorithms works, and hopefully if by doing it and seeing the operations on the array, you can have a better understanding of how these algorithms work. This can be useful for merge sort and binary sort and the searching algorithms. It helps um, to do it by hand so you can see exactly what's going on. And again, I recommend that you go watch an animation of this happening. Like Geeks for Geeks is a good one. Um, Maybe I should have done their array and then we would have been able to see it. But anyway, this is literally half the length of what I had recorded before. So mission accomplished. Um, Hopefully that helps you. If you don't understand it, please email me so that I can try to like clarify some of this stuff. But other than that, I'm going to go ahead and end the video here and get it uploaded. Thanks for watching, guys.